end of the webinar. The Q&A icon is located at the bottom bar on your screen. So without further ado, let me now introduce you to Yang Bahagia Datuk Engineer Abdul Kadir bin Mohammadin, President of the Malaysian Water Association, for a short welcome address, and thereafter followed by Mr. Gary Wyeth, Managing Director of Wyeth Water Consultants Malaysia, our speaker for today's topic. Abdul Kadir, over to you.
Hello. Hello, thank you, Denise. Hope everyone can hear me. Okay, done, thank you. Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Salam sejahtera, ladies and gentlemen. Good afternoon and welcome to the brave new world of COVID-19. So, while it is too early for us to assess the damage caused by this global pandemic, we see there are signs that it will be permanently changed the way society functions. So from its impact on the global economy to our daily lives, COVID-19 will leave an enormous impact on how we consume, how we learn, how we work, and how we socialize and communicate. Work-wise, streaming content online has become massively popular over the last few weeks in Malaysia, especially in the face of COVID-19 MCO pandemic. I'm glad to have this opportunity to get connected with the MWA members today through this Zoom webinar on controlling NRW after successful implementation. Certainly during this COVID-19 MCO, webinars and training via Zoom or similar application, streaming will become an even more critical and dominant way to deliver content and connect our members. The MWA will certainly be developing this platform to communicate with members instead of the new normal. You'll be looking forward that we will have more of such webinar in the near future. This is also because although MWA live events will eventually return after the current crisis, I predict that live and recorded streaming will surge in popularity, and MWA will maintain these options to reach out to our members and the consumers. Coming to today's webinar series on non-revenue water, we all know that non-revenue water within a utilities network is a huge source of wastage. It adds greatly to the operating costs, and leaks can be big complication and expense to the sustainable management of water services. From both financial and environmental viewpoints, we simply cannot afford to ignore non-revenue water any longer. Inefficient system, inaccurate methods of measurement and substandard policies, as well as inaccurate data must be relegated to the past, and new era of openness, accuracy, and economics must take its rightful place. Hence, the Malaysian government had over the last couple of years taken the initiative to give emphasis and refocus on tackling the NRW problem with more budgets and some incentive for achieving set targets. All of us have a good understanding of NRW issues and challenges, but somehow along the way, the implementation were not sufficiently holistic. This brings us to today's discussion. Why is it that often after the implementation of NRW program undertaken by some water utilities, we seldom see continuous dedicated management and operational follow-up to ensure the initial goals achieved from the program are continually monitored and sustained or brought down further? In relation to today's webinar topic, I wish to reiterate that NRW management is not a one-time activity. Although an intense comprehensive NRW reduction program is suitable to reduce the backlog of required NRW reduction measures, it will not lead to a sustainable low level of NRW unless NRW management becomes part of the normal day-to-day activities of water utility. Here are some of the key facts to start off that you can have these facts as a ponder. On the basic facts, three categories of NRW losses. Physical losses, that is about 3/4 of it. Commercial losses is about 1/4, and unbilled, unauthorized consumption is about 1 to 2%. That's based on statistics. So if you look at the current state of Malaysia, we have about 41,560 kilometers of old AC pipes. And this is about 30% of the total pipe that we have in nationwide. And the old meters, more than 10 years old, tend to under-register. So for Peninsula and Labuan, for example, in 2018, over 4,900 MLD are classified as non-revenue water, with average rate of water loss of 33.9%. This works out to costing water utilities billions of ringgit per year. Technically, we can bring the losses down to 35%, meaning up to 75% of current water supplies in system are recoverable. Sabah and Sarawak are further dire position according to the statistic from the Water Supply Division of the Ministry of Environment and Water. Both Sabah and Sarawak NRW hovers around 50%. So if you look at the earlier estimate, we need about 13 billion to reduce to the NRW to 35% by 2020, which we are nearly there, but I think so we can achieve that 25%. And if you need about 77 billion working capital to upgrade pipelines and reservoir. Another 13 billion required to reduce losses due to aging equipment, and the RM 1.39 billion allocated for year 2020 to change main pipeline is definitely insufficient. So hence, looking at these simple key facts, the truth is there are costs associated not addressing non-revenue water to a sustainable level, and that cost will do nothing but escalate every delay. So it was estimated that it required about 0.8 to 1 billion to reduce 1%. So it's my hope that today's webinar topic will get rekindled in all water players to see the value in pursuing non-revenue water initiatives. There is always something new to learn about this extensive topic. And I also hope that if our water utility is not actively pursuing non-revenue water and continuing in it, it is time to consider before you are forced to do so by outside parties, thereby losing control of the process. Take the first step forward toward ownership and good stewardship of your water resources, and you can begin to see what is possible. Finally, we need to understand best practices that are shared among the water players and the need for exchange of experience perspectives. And that is what we are doing through this series of webinars. I would like to thank you all for your participation today, and also to the Proton Group, the MWA Event Manager for the Malaysian International Water Convention 2021 for sponsoring this event. Hope to see you all in future MWA activities and webinars. And I wish you all a fruitful succession discussion. Last not least, stay home, be safe, and together we can win. Stay connected. Thank you.
Thank you, Dato, and hopefully I can share my screen now. Okay, so thank you everyone. We seem to have quite a big crowd today, which is very encouraging. It just shows how important people consider non-revenue water to be here in Malaysia. So as mentioned, I'm going to be basically presenting on controlling NRW and mainly focusing on after successful implementation. So this is continuity of NRW programs. If we look at Malaysia as a whole, Peninsula and Borneo, there are a number of utilities which are based mainly on the states. So each state has its own utility. And there have been a number of non-revenue water contracts over many years, over the last 20 plus years. Those holistic contracts have been just about in every state. Probably the two that are not shown on here are Penang, and that's obviously because Penang have done in-house non-revenue water management for the last 20 years. And Perlis. I think Perlis is about the only state that hasn't had a holistic NRW contract to date, but I may be wrong. What's interesting also is that we've got Selangor and Malacca that were working with a holistic contracts in terms of third-party contractors doing them, but they've now both moved to doing it in-house, which is quite interesting. But if we look at the non-revenue water levels, you can see that considering the number of holistic contracts that we've had in all of the different states, we still have very high levels of non-revenue water across Malaysia. There's only 3 utilities that are actually below 30%. And we've got 4 utilities that are up near 50% and above. So what is the problem, and how can we get utilities thinking about how they can continue doing non-revenue water after these holistic programs finish? Well, the issues that we really need to be looking at, or the issues that I consider, the first one is finances. So it's how do the utilities go about paying for these non-revenue water continuity programs? Because as I'm going to show in a minute, many of the utilities are not operating on 100% full recovery, which means that they need subsidies from the government. And this also means that the utilities tend to focus more on CapEx expenditure because it's easier to develop a CapEx program and then get money from the government on those CapEx projects. They also tend to be lacking in skills and lacking on skills in equipment, non-revenue water equipment as well. And it's a bit of a shame that although these water utilities have had holistic programs, that there hasn't been a transfer of knowledge or a proper transfer of knowledge from the third-party contractors across to the utilities staff. That can be down to a number of issues, but there should be a more emphasis by the upper management in the utilities for their staff to start taking over the non-revenue water management programs after the third-party contractors programs finish, and that they should be learning those basic skills. Manpower, another issue that we often have is that with the government-based utilities, we get staff that are moved around from department to department quite regularly, which means that they don't become dedicated in one specific department. So that means you don't have a focus and you don't have people retaining the skills that they should be having. And one of the other big factors is motivation. And a lot of that comes from the management. And it's whether there is an emphasis on NRW as a key part of the utility, or whether management just see non-revenue water as just a minor thing that they have to keep doing just to please the government. And then equipment. Do utilities really invest enough in equipment to enable the NRW teams to manage the NRW properly? Do they have the finances, once again, to be able to develop that equipment? And we're going to look more closely at finances. So often when we're looking at the non-revenue water in a water utility, we tend to use the IWA Water Balance, which you can see here. And on the right-hand side, we have revenue water and non-revenue water. And quite often in not just Malaysia, but a lot of countries, they tend to use percentages in terms of analyzing the non-revenue water and how high the levels are. Now, if you can manage your revenue water, if you can increase revenue water, you're actually going to pull down the non-revenue water percentage. You're not going to necessarily reduce how much water is being lost, but you're going to increase your revenue, which is always good, and you're going to decrease your non-revenue water as a percentage of the entire system input. So let's have a look at finances. And this is the top bit. This is the revenue water. And What we want to do is we want to increase the revenue water as much as possible. And you can see here, this is actually a contract that was undertaken in Malaysia and for one of the utilities. And you can see here that the revenues on a year-to-year basis are actually increasing from 2013 up to 2014, 2015 up to 2016. And this increase that was going on a year-by-year basis was actually down to customer meter replacement. So those customer meters that were being replaced were actually seeing an increase in revenue that was going to the water utility. Now that increase in revenue is something that we're looking at because it's often what we call the virtuous cycle. And you can see here that as our revenues increase, we can actually spend more of that money. So that revenue that's increased, some of that revenue can be used to invest in further NRW programs, maybe pressure management, maybe protection, or even more meter replacements. And then that will help to reduce the NRW even further, which will then give us more revenue or decreased operational costs, which will then improve the water utilities' revenues and profits, which is what happens. Utilities work in this circle and they gradually improve, which is why a lot of non-revenue water programs take a long term. They can be 10, 15, 20 utilities like Selangor's been, I think they've been doing non-revenue water for over 20 years. Johor is 15 years, that's been ongoing, and they're still working at it now. So this is something that's not going to happen quickly. Now, the issue that we have with holistic programs is that often they can only be limited in length, maybe 3, 4, 5 years. So because we're looking at that longer period, it is the utility that needs to take over once the shorter holistic program has finished. Now, if we look at the finances, and this is data that's come from the SPAN water and sewage statistics. On the left-hand side here, you can actually see the average revenue per meter cubed for all of the peninsular states. And then on the right-hand side, you can actually see the average total costs. And what is quite clear is that there are many states, for example, Kedah, Kelantan, and I'm just Malacca, Negeri Sembilan, even Penang, where the average revenue is less than the total costs. So this means that these utilities are not making enough money to actually be able to pay for their costs, all of their OPEX and all of their CAPEX. So this means that the government has to, either at a state level or a federal level, has to subsidize these utilities to be able to cover their costs. Now, this can be done at a for political reasons, because you want to keep the people happy, or you don't want to increase the water rates too high. But if that's the case, there needs to be a fixed subsidy so that the water utilities know exactly what they're going to be getting on top of the revenues from their metering. The real reason that we can see is that the tariffs are just too low in many states. And some of the tariffs in some states haven't been adjusted for over 20 years. And I wouldn't say it's because people are not willing to pay, but it's because it's seen as a political thing, and especially when it comes up to election years. So if you were, let's say you were a state like Pahang here. So Pahang has average revenue of 79 ringgit per meter cubed, yet their total costs are 1.39 ringgit per meter cubed. So if they were to do a lot of NRW work and they were to increase their revenue here from 79 even up to 1 ringgit, they're still not going to be covering their costs. So do you think that the government is going to say, oh, don't worry, we'll keep the same subsidy for you so you can have extra money to spend on extra projects? Or will the government just say, oh, that's nice, we don't have to subsidize you as much this year? And I believe it's the latter. And so there's a real lack of motive or incentive for these water utilities to actually reduce or increase their revenue or reduce NRW, because all that will happen is they will actually get less subsidies from the government, which means that they don't really have to work as hard to manage their revenues. So there needs to be a look at revenues of how these water utilities manage their revenues and the subsidy side of things to, in fact, to try and make them all 100% full cost recovery so that they all become proper businesses and they actually have to manage themselves so that they have to manage their revenues to ensure that they have enough money to actually do their projects, OPEX and CAPEX, over the next year or so. Now, this is becoming even more critical now that we're in this COVID-19 situation. And there's already been some articles in the news about water utilities that are starting to look at the challenges that are going to happen over this COVID-19, especially with all of the industrial and commercial customers that are actually shut down. And they've been shut down for over a month and will probably be shut down for another month. So that means you've got 2 months of your customers that actually pay the most. Your industrial and commercial customers are like your business class seats in an aeroplane. They're the ones that fund most of the revenue that's coming in, and the economy passengers in the back, or your domestic customers, they're the ones that are being subsidized by your industrial and commercial. So you can see here that this utility in the Bahamas, they reckon that over 1 month in April, they've actually lost 60% of their revenue. And there's another utility here in the USA, in central Arkansas, that's saying over this year, they will actually see a 6% drop in total revenue for the year. So what's going to happen there? Are the governments going to have to subsidize that loss that's happened over that period of lockdown? And how do the governments actually work out roughly how much it is? Or do the utilities have to start looking at cost saving measures? Do they have to say, okay, we've lost money this year, 6%, 7%, 8%. So we're going to cut down some of our programs. And probably NRW would be one of the programs that they would look at and say, well, maybe that's not so critical. But fortunately, there are people out there, and you can see here, who believe that this situation where you actually have lower revenues coming in is an ideal situation to boost the non-revenue water activities, because they're the ones that are going to help you to increase your revenues further and also decrease your operating costs, especially if you have a lot of repairs that need to be done or mains replacement. Hopefully, once we've got through this year and we get into next year, we'll be able to start getting back onto normal footings. Now, when we're looking at commercial losses, this is how we manage the finances, how we get our revenue up. We tend to look at this 4 pillars of commercial losses. And there are 4 activities that we would be looking at. Meter reading errors, so people reading the meters, accounting errors from your billing systems, meter under registration, and water theft. Now, Fortunately, in Malaysia, I think nearly every water utility uses handheld meter reading devices, which means that meter reading errors are almost zero, which is good. They then use those handheld devices back to the office, and all of the data is sucked into the billing system. So accounting errors are almost zero. And even water theft is quite minimal here in Malaysia. So really, meter under registration is probably the major issue that we have in terms of commercial losses, which are affecting the revenue of your water utilities. And the big factor that we have is actually meter accuracy over time. So as meters get older and older, they actually wear and tear, and we need to replace those meters. At what age do you need to replace them is a different discussion entirely. And I know that we have another webinar next week on metering. They may mention that, but there needs to be a target of when you need to start replacing meters, if it's 7, 8, 9, 10 years. It's something that each utility needs to work out themselves. But once you've set that target, you need to make sure that you are replacing meters once they reach that age, whether you think they're still accurate or not, because they could drop off very quickly and lose their accuracy. And of course, when you are replacing those meters, you need to make sure that you're replacing them with good quality meters that are going to last a long time and are not going to start failing very quickly within the first 3, 4, 5 years. So cheapest is not always best. Make sure that you're buying a good quality meter and that it's being installed accurately. Now, going back to the water balance, the other major component of non-revenue water that we have here in Malaysia is actually physical losses. And those physical losses are the thing that we need to concentrate on the most. We have active leakage control, speed and quality of repairs, asset management and pipe replacement. And I'm going to talk mainly about those three, because these are the things that utilities need to really concentrate on once the holistic programs have been completed. The holistic NRW programs are basically going to get the monitoring situation in place. They're going to replace all of the customer meters. They're going to set up DMAs so that we've got flow going into different areas, and we're measuring each DMA and understanding where we have physical loss problems. And the holistic programs are going to do pressure management in most cases, set up PRVs and put on advanced pressure management on some of them. So in this webinar today, this presentation today, I'm not going to talk much about pressure management, but I'm going to concentrate on the other three. These are the main three that the water utilities need to do as a continuity after the holistic programs have finished. So let's start with active leakage control. Leakage is a problem for all utilities. It doesn't matter how low or how high your non-revenue water levels are. Leakage will always be there, and you'll always be having new leaks or bursts happening on a weekly, if not daily, situation. Now, leaks can happen and be left unknown for weeks or months, depending on how much work is done by the utility to actively look for those leaks. And if we don't have sufficient leak detection teams and activities going on, what we will see is that the levels of leakage will start creeping up, especially after the holistic third-party contractors have left. Now, if we look at leakage itself, we tend to break it down into 3 different types of leakage. We have reported leaks. Now, these are what we also call visible leaks. These are leaks where the water comes to the surface and you can actually see the leaks or where the leak is coming from. We call it reported because generally somebody, either the public or somebody in the utility staff, will actually report that leak or phone in on the hotline and say, there's a leak, come and have a look at it. Then we have unreported leaks. These unreported leaks are the buried leaks. These are the ones that are invisible and the water where it maybe just seeps down into the ground or runs away in a river or a drain. And the only way that we can find them is to do active leakage control. And then we have background leaks. Background leaks are the very small leaks like weeping joints or very small pinholes that are basically not cost effective to find and repair. The only way to really do background leakage is to do pressure management or to do mains replacement. So what we're really concentrating on are the reported leaks and the unreported leaks. And it's generally known that for every leak that is visible, there are 4 or 5 buried leaks, unknown leaks that are underground that we need to find using our active leakage control. Visual inspections are probably the most basic way that we can look for leaks, especially these visible leaks. And these are fairly easy to spot because just by walking around or even driving around, you should be able to see these visible leaks. And as I mentioned, we also get calls coming in from the hotlines from people reporting these leaks. These are not what we would call too much active. This is just reactive. So as soon as you see the leak or somebody reports it, you go out and fix it. Now, for those buried leaks, those are where we need to start using equipment. And the basic way is to use basic sounding. So we have listening sticks, just mechanical sticks. We have electronic sticks that amplify the leak noise. And we have ground microphones. So in this technique, it probably doesn't need too much skill, but it still needs a bit of training and skill. But people need to be walking large areas of a zone. So you need to, first of all, identify where you think you have a problem, where you have a leakage problem. And this comes down from your DMA monitoring. And from your DMA monitoring, you might identify a DMA that has an issue. You can then do step testing to maybe break that down further into a small area. And then you need to go out and start sounding on any fitting that you can find. A fire hydrant, an air valve, a washout, a customer meter, anything where you can put your devices on and start to listen for the noises. Also with ground microphones, if the pipe is not too deep and the ground conditions are quite good, you'll be able to just listen to the surface, the ground surface as well. Now, these devices are not necessarily going to pinpoint where the leak is, but they're going to generalize where a leak is, and then you can move into other devices that you could then pinpoint. You could also move into more sophisticated sounding. Probably the most common one that's been used over a number of years now is leak noise logging. And that's where we have these electronic devices that we install in your DMA at different points, either temporarily for a week or 2 or permanently listening for the leaks. And what these devices do is they sit there, and at night time when the background noises are quieter, they actually listen for the leak noises, either existing leaks or new leaks if you have them permanently monitored. The latest technology, which has happened over the last few years, is that these noise loggers can also do correlating. So they can actually, once they detect a leak, they can pinpoint as well. And obviously what you're looking at here is a ramping up of your active leakage control, because it's going to cost you a lot more money to be buying a lot of these leak noise loggers and installing them and managing them as well. And then leak noise correlators. So these are devices where we can actually pinpoint leaks. If you don't have the leak noise loggers and you suspect there's an area that does have a leak, you can actually put these correlators on those pipelines to pinpoint the leaks and to verify that there is a leak and where it is. So when we're looking at all of these technologies, from basic sounding to noise logging to correlating, they all need a fair amount of equipment, and you also need a fair amount of staff and skilled staff who know how to use this equipment. And probably more than the skills, you actually need staff who are dedicated to what they're doing. They need to be people who you can send out and you tell them there are leaks in this area, and those people would go out and really look for those leaks. Not just do a half-hearted job and come back and say, oh, we couldn't find anything. And even though you know there are leaks out there. Now, large diameter mains is quite interesting, because most holistic contracts that have happened in Malaysia have concentrated on distribution networks, looking at DMAs, doing pressure management in DMAs, doing leak detection and repair in DMAs. Very few, if any, have looked at trunk mains. I think the only utility that's really looked at it is Air Selangor. And they've done a real massive program of their trunk mains. And they've actually been very successful. They found a lot of leaks on their trunk mains. And this doesn't mean that their trunk mains are more leaky than anybody else's. So I can guarantee that all of the trunk mains across Malaysia and all the utilities will have a lot of leaks on those trunk mains. And what makes it worse is that these trunk mains tend to have higher pressures, and they also tend to be made of a stronger material, metallic material. So when they do fail, when there is a leak or a burst, at that high pressure and that sudden failure, you can actually have a lot of damage that's done not just to the pipelines, but also to the surrounding area. And what makes it really critical is that there's often a lack of redundancy. I remember when I first started for a utility in Malaysia in 2003, my first day of work, I walked in and there was nobody there. And I said, where is everybody? And they said, oh, we've had a major trunk main burst. And that burst took out a large area of the district that it was in. And it probably took about 4 or 5 days for it to be repaired and for it all to be back up online and for the pressures to be back up there. So trunk mains are an area that utilities should be looking at. And if you are developing holistic programs for the future, make sure that the trunk main leak detection is put into those holistic programs. I can guarantee you that it will be successful. Now, repairs. It's essential that when we do repairs, that we actually use proper materials. And I think in Malaysia, I think most utilities do try to use the proper materials. Maybe people don't tend to use repair clamps, but maybe they use these couplings. So these couplings would be where you would cut out a piece of pipe where you have the leak, the burst or the crack, and then you put couplings in. But what's key is that you procure the right materials, making sure they're good quality, making sure that, that they're going to fit for the right pipe size and the right pipe material, so that you're not going to have problems with those couplings failing either from the material not being good enough or for them not being the right size. So procurement of the materials when you're doing these repairs is critical as well. And here's an example of a poor repair where you can see that somebody has actually cut out the road and they've dug down, and I would assume that they've actually made a repair and then they've reinstated it or covered it back over, but it's still leaking. So, or maybe it's not still leaking, but it started leaking again. So making sure that when you do a repair, you do it right the first time and you do it properly the first time is key as well. It's a key part of your work to make sure that you're not going to have a backlog of repairs that just keeps on growing. And talking of backlogs, you can see here that this utility, it's not in Malaysia, you'll be happy to know, but this utility has actually mapped out all of the leaks that have been detected, and it's put all of those leaks onto a GIS map. And all of the green dots that you can see are actually leaks that have been repaired. The red dots are outstanding leaks. These are leaks that are waiting to be repaired. So you can see there that they have a huge backlog of leaks waiting to be repaired. And if you are a non-revenue water or a leakage detection person and you find a leak and then you go back there months or even years later and it still hasn't been repaired, it's very disheartening and it makes you think, why do I bother finding these leaks? So getting leaks repaired as quickly as possible not only reduces your leakage volume, but it also helps with the motivation of your staff who are actually doing the leak detection. Now, mains replacement is probably one of the key factors of any utility's non-revenue water management. And that's because as pipes get older and older, they actually get weaker and weaker. And eventually they get to the point where they're just so weak that they can't sustain the pressures that we're putting them under. And the problem is that utilities don't invest enough in mains replacement to actually keep on top of the pipes that they have in poor condition. So quite often when I go to a utility, I always ask the question, what is the life expectancy of your mains? And people will often tell me what they think they believe their pipe should be, 30 years, 50 years, 80 years, or some of them 100 years plus. I know in many countries, they have pipes that are over 100 years, some 150 years old. So when people tell me that their pipes are only going to last 30 or 40 years, it seems to me a bit of a shame that you're spending a lot of money on an asset which is not going to last you as long, when if you did it properly, it would actually last much longer. But if we look at replacement, assuming you have a life expectancy of your pipes of say 50 years, that means you need to replace all of those pipes within those 50 years. So if you have 10,000 kilometers of pipe, you need to replace 10,000 kilometers of pipe within 50 years. And so that you don't have a large backlog of pipes that need replacing at the end of that 50 years, you need to be replacing about, on average, about 2% per year. If you drop below 2%, you're actually going to start to build that backlog up, and you'll get to year 25, 20 or 30, and suddenly you've got 60, 70% of your pipes that are failing. And where are you going to get the money from to replace them then? Not just the money, but it's all of the effort and finding the contractors, digging up all of the roads. So keeping on top of your 2% per year is critical. You may not think it now, but in 50 years' time, when the people that inherit your water utility in 50 years, they're going to thank you, because at that point, they've only got to replace 2% per year, and they've got a very strong pipe network. Of course, if you can extend how long your life's expectancy of the pipes will be, that means you only have to reduce a lower percentage. If you can get your pipes up to 100 years in life, you only have to replace 1% per year, which is a much better situation than replacing 2%. So how do we increase the life of our life expectancy of our pipes? There's really two options. One is to install good quality pipes using a good construction method from initial installation. And unfortunately, I don't believe that's done in Malaysia in many utilities. The installation of pipes is done, especially at distribution level, is done very cheaply, often done by developers when they're developing housing areas and using not very good standards of construction. And this leads to many problems later on. Or, and this is what most utilities do, they wait until the pipe is in a weak state, which sometimes can be after 20 years, and they start to undertake pressure management to drop the pressures really low to reduce the leakage volumes, and to start doing leak detection and repair activities in a sort of firefighting role. I remember working in one utility where we would have some DMAs that would have 40 to 50 leaks every month. It didn't matter how many you repaired, the next month you would have 40 or 50 new ones. And it's at that sort of situation where you know your pipes are just gone and you have to replace them, whether they're 20, 30, 40 years old. The sort of things you need to be looking at, how do we make our pipes last longer? Storage. Before you even put the pipes in the ground, they need to be stored properly. On the left-hand side, we've got PVC pipe, which is just lying out in the sun. Now that means that PVC pipe is going to bake and it's going to become brittle. And that, when you put it in the ground, any sort of like pressure on the pipe, either from soil movement or even rocks pushing on the pipe, is going to crack it and cause a leak to occur almost immediately. And then on the right, you can see these mild steel pipes have just been piled up on top of each other in a ditch, and you don't know what the condition will be like. Well, we do, because I've got some pictures. And you can see here, we've got ends of pipes that have been bashed in here. And we've also got pipes where they've been lifted off the lorry using chains without any protection, where the coating has been ripped off. Now, do you think that the contractors that were putting these pipes in threw these pipes away and said, oh, they're not good enough quality? No. They would have quickly put them in the ground. They would have knocked out this bit here, welded it all together, covered it up and said, that's fine. But what will happen is, even within a matter of a few years, we're going to start to get leaks on the joints, and also leaks at these points here where we've got bare metal touching the soil. So ensuring that you store and handle the pipes is the first step. The next step is actually protecting the pipe for its whole life. And the best way of doing that is to actually have a surround around the pipe of nice soft material. We call it a granular fill, but quite often this would be a sandy material. So what we would do is we would put out a bottom layer of sand and we would compact it to get rid of any air that's in it. Then we would put the pipe in. We would then backfill with more sand and compact it again. Then we can put all of that material that was dug out of the trench initially on top. And then we put on a final layer if we're going to be putting a road surface on top. If not, you could use the dug material all the way up to the top. What I often see in Malaysia is people put the pipe onto the ground, the bottom of the trench, and then the dug material is just dumped straight on top. which means you've got hard material which is pushing against the pipes. And also you're going to get large air pockets, which as soon as we get rain and rain starts to get in there, you're going to get ground movements, the pipes are going to move and the joints are going to start to leak. So there's lots of issues that can happen if we don't have a sand surround of your pipes, which is not compacted properly. So this is something that I believe all pipe or mains replacement projects should be doing in Malaysia, if they're not doing it already, to ensure that your pipes are actually going to last, 30, 40, 50 years longer than they currently are. Here we can see a couple of poor installations. The one on the left here is where the pipe was put into the ground, but it wasn't compacted properly. And what has happened is there's obviously been water got in there, either from rain or from a leak. And what's happened is it's actually washed all of that material on top away. And here is another situation where the pipe was actually buried and the dug material was dumped on top. And then as traffic drove over it, a rock was pushed into the pipe and it just cracked the pipe. And you can see the crack that's running along there. So when we're talking about NRW management, and we talked earlier about holistic contracts, and we also talked about in-house contracts. Now, a lot of those holistic contracts are done by third-party contractors. And you can see here a number of states where they had third-party contractors. I've missed Sabah off, but Sabah also has a third-party contractor that's doing NRW there. And we also have, the Sabah one is still ongoing. So the green dots are actually holistic projects from third-party contractors that are now finished. And that means that the utilities are now having to manage it themselves. The yellow dots are the ones that are still ongoing by third-party contractors. And then, of course, we have the in-house non-revenue water management. And we can see that at the moment, we actually have 3 utilities that are doing in-house NRW. Penang, as I mentioned at the beginning, are doing it. IWA Selangor have now taken over from the third-party contractor before and are doing it in-house. And the same with Malacca. They had a third-party contractor and they're now doing it in-house. And if we now look at what is better? Is it better to do it in-house or is it better to do by a third-party contractor? I would basically say there's pluses and minuses for doing both. I mean, if you're doing it in-house, it's going to be more cost-effective. By getting a third-party contractor, you're going to be paying them more money. The reason being is that they tend to be working on performance-based contracts. So you're paying them more money, but you're paying them more money because they're guaranteeing performance. With in-house, you tend to have staff which they may be moving around from department to department, and they also may not have a dedicated role in terms of managing non-revenue water. So that's why the third-party ones tend to be more expensive. You can also, there also needs to be good communication, because to do non-revenue water, a third-party contractor can't do it all themselves. They still need the support of the utility to do things like the meter replacement, the meter reading, the billing. Mains replacement obviously is often is not part of the holistic contracts. So there's still a lot of work, and also approvals of doing different activities needs to be done by the utility. So there needs to be good communication between the two. Now, that communication is a lot better if it's being done in-house, because the water utility NRW team can actually talk with the operations department, the production department, and they can work together on how things are going on. But probably the biggest change of doing it in-house is the mindset change from the top management down. There really needs to be the top management saying NRW is critical and this needs to be done, either in-house or third party actually. And that then helps everybody in the utility to appreciate that they need to do something to improve the non-revenue water. And of course, the other thing is these NRW contracts often require a huge workforce. If it's being done in-house, the utilities often have to take on full-time staff to do that. Whereas a third-party contractor may often have contractual staff on a yearly basis. So it can be easier to manage staff as a third-party contractor as well. So like I said, there's benefits and cons for both ways of doing it. If we look at the state NRWs again, the chart that we looked at the beginning, you'll see that the three utilities that are actually below 30%, we have Malacca, we have Penang, and we have Johor. It's very interesting to note that, as I've mentioned, Penang has been doing it in-house from the beginning. Malacca used a third-party contractor, but then moved to in-house. And Johor has been using a third-party contractor for 15 years. So all three methods have actually shown good results. And so it's just sort of indicates that no one method is the right way to go. All three methods will work if you have the right management, and the right management who believe that NRW is critical and that it needs to be brought down. So the challenge that we have for NRW, it needs to be looked at from all departments. Setting up an NRW team, which has maybe 10 or 20 people in it or less, is not going to help you to reduce NRW, especially if all the other departments, like the billing department, the operations, the productions, can say, oh, NRW is the NRW department's responsibility. You need to have a proper strategy, especially if you're doing it in-house, to make sure that everybody understands that it's everybody's responsibility. And that's quite often why the first step of doing any in-house NRW program is to have an awareness program. And that awareness program needs to be for every single staff member. Every single staff member needs to know, what is NRW? Why is it important? And how can I help to reduce it? But it all comes down to being a management problem. And when I say a management problem, I'm not necessarily saying the utilities management, but even higher than that, the board and the government. Everybody needs to look at this and make it a major priority, which includes the financial side of things, so that there is enough money to ensure that the continuity is there. There is motivation for everybody, from the staff down that are doing the work up to the top management, who are the ones giving the direction to the utility. And there needs to be training. The management need to ensure that everybody is trained, from awareness training to skills training, to ensure that everybody can work together to bring non-revenue water down. Thank you. I think that ends what I've got to say. So I think the next step is to move to Q&A. And we have some questions already, which is very good. And apologies if I announce the names wrong, but we have one, or maybe everybody can see the questions, so I don't need to say the names, but we have one. May I ask if you can comment on the feasibility of implementing a domestic water reuse scheme as per Singapore? It is possible, but the problem is how you actually do the reuse yourself. Because if you have a utility that has, let's say, 100,000 meters, I'm guessing now, 100,000 meters, and you're going to be replacing them on a 10-year basis. So that means every year you're replacing 10,000 meters. So that means that you're only going to be doing reuse. So you're repairing or replacing the meters only on a small volume. And it's whether you can actually maintain the quality of reusing those meters or replacing the parts to ensure that you're going to have a meter that's going to last for another 10 years. I mean, it's all well and good buying spare parts and putting those spare parts into the body and then testing it on a test rig and saying, okay, it's accurate. But it's getting it right so that you can maintain that accuracy for then another 10 years. I mean, for the cost of the meters that you can buy meters from, I would say stick with buying from the proper manufacturers who have got the experience in actually manufacturing and maintaining the accuracy of those meters. Next question. Do you think that we need to do the survey willingness to pay in order to increase the tariff? Well, yes, we probably do, but I think when you look at what people have to pay at the moment, bills, water is not the only bill that people pay on a monthly basis. They pay for electricity, they pay for their mobile phones, they pay for food, they pay for petrol. All of these items that I've talked about, they all go up. The prices go up. Electricity goes up every year. The electricity company doesn't need to go and get approvals. It just goes up every year. Oil prices change all the time on a week. Oh, sometimes they go down, but sometimes they go up, but they generally go up. Phone bills. Nobody complains when they get a phone bill, which is a few hundred ringgit. But if their water bill goes from 10 ringgit up to 12 ringgit, they jump all over the place. So I don't necessarily think that there is a need for a willingness to pay. I think people will pay if they think they're getting a good service. And if you look at some of the utilities, I mean, I didn't mention it when I showed the table, but some of the utilities already have higher tariffs, like Johor. And Johor has a higher tariff, but they also have a lower NRW. And we don't see people complaining in Johor because their tariff is high, because the water bills are still lower than the other bills that they have to pay on a monthly basis. So I do believe that people appreciate water already, and just increasing the price a bit would not upset them. Would like to have the statistics for Sabah and Sarawak for NRW. Yeah, I was having a look at this, and the only figures I could find, I was looking for the latest figures, and the latest figures were from SPAN, and unfortunately Sabah and Sarawak are not in the SPAN scheme. But I do know that MWA is coming out with their new report, which will be out this year, if it's not already out. Maybe Dato can clarify that, but I'm sure that the figures will be in that report when that comes out. Can I share the slides? Yep, sure. If I don't know how to share them, but you can see my email at the bottom. If anybody wants the slides, please email me and I will send them to you. Oh, okay. So I think I can click some of these. Can you tell us the details used in calculating OPEX? And what is the highest component cost in operating expenditure? So when you're looking at OPEX, there's a number of things that are actually involved in it. If we start at the treatment plants, you've got chemicals, you've got electricity for running the plant, you've got staff levels. Sometimes you actually have to buy the raw water, so you've got the cost of buying the raw water as well. Then you move into the distribution, so you may have pumps where you need to pay for electricity, maintenance of parts, replacement of parts, staff costs again, maintenance of valves, replacement of valves. Then we move into the billing side where we've got meter readers, staff costs, you've got your equipment costs, you've got vehicle costs. So OPEX covers a huge part of the water utilities expenditure. There's many things that need to be covered under OPEX. And then the other one would be CAPEX, which is putting new pipes in, putting new reservoirs in, maybe building a new treatment plant, a new building. Those sort of things will become CAPEX. CAPEX is often something which you can defer repayment. So if you're going to spend money on a new reservoir, you pay it back over a number of years, but OPEX is something that needs to be covered in that year. We have a problem with crowded area or noisy area. What is the best way to pinpoint the leak? Well, the best time is to actually find the period where your noisy area is not noisy. So generally when people are looking at it, they tend to look at nighttime. So they look at between 1 and 4 o'clock in the morning, because most factories might be shut down, most restaurants, shopping malls will be shut down. So the noisy area has gone. So that means that you can concentrate on the noise. If you can, go out now, because there's nobody out at the moment. So you should have no background noises. So this is the perfect time, if you can convince somebody that you're a key worker, to go out and find those leaks. The next step is to actually move up on the equipment that you're using. So I mentioned about the basic sounding. Well, they're probably not so good when you have a lot of background noise, but when you get down to your noise loggers and also the correlators, where you can use hydrophones as well, that will help you to detect the noises with the higher backgrounds. A lot of these high-tech equipment now, like the leak noise correlators and the leak noise loggers, they actually have very good filtering systems where they can filter out a lot of these background noises. So it may be that you're using the wrong equipment, or maybe you're using the right equipment, but you just need a bit of training in how to use it properly. Is there any efficient and economic alternative to large diameter trunk mains? Well, the only alternative is to have lots of smaller treatment plants. So instead of having trunk mains that distribute your water around your network, you basically have lots of small localized water treatment plants. Now, there you have pros and cons from that as well. Obviously, if you have lots of plants, there's a bigger cost associated with building them and operating them than there is from building and operating one or two big plants. But on the offset of that, you don't have to put in those big, large trunk mains, and you don't have to manage them and worry about bursting. What is the method for finding leaks in transmission pipes? So it's always been an issue that that large diameter pipes, because what we're doing when we're trying to detect leaks, we're actually listening for the leak noise, the noise of the water as it escapes the pressurized pipe. Now, the problem with large diameter pipes is that the noise doesn't travel as far from the leak source, and there's always been problems with the pipe material because the pipe material, because it's metallic as well, it's thinner compared to the overall diameter of the pipe. But there has been a lot of technology or research done into technology on trunk mains over the last 10 years. And now people are using hydrophones. So this is, instead of listening for the noise on the pipe material, you're actually listening for the noise in the water in the pipe. And noise travels further in water. And so by listening using hydrophones, you can actually listen for the noise in the water, and you can detect the leaks a lot better. And there are a few manufacturers. I know Ecologics is doing stuff. I mentioned Isolangle, which is Ecologics, but there are other manufacturers that are looking at it as well. There's also a company that's looking at transients. So when a burst happens, it actually creates a transient, a surge, a pressure surge down the pipe. So if you have a pressure sensor that can detect that pressure surge, you can actually, not necessarily pinpoint, but you can detect that a burst has happened and identify the rough area where it has happened as well. So there's a Vicenti, or Xylem is the company that's looking at that as well. So there's a couple of technologies that are being looked at for transmission pipes. What's your opinion about the best distance for ferrule tapping at the main? That's a good question, and I'm not really an expert on that that detail. I think I'd have to ask someone else and maybe get back to you on that, because it's not something that I would know myself. Somebody else asking for the slides, and I have said yes. You can see my email address below. People can email me and I'll send the slides to you. I'm interested in the leak detection method based on my simple research. The usage of leak noise correlators are very good and accurate, but the constraints when using leak noise correlators is quite expensive. Not so cost effective in detecting leaks within a DMA. Is there any suggestions or discussion of other methods to detect leaks accurately, yet maintaining low cost operations? Yes, I mean, I did mention it briefly, which was to do step testing. So this is where you actually have a DMA. You may have high leakage in a DMA, but what you can do is you can break the DMA down into smaller areas and identify where the high leakage areas are in that DMA. So what you may find, rather than having a DMA that's got 5 kilometers of pipe that you need to correlate, you may be able to narrow it down so that there's only 500 meters or a kilometer that's got really high leakage. So that means that you can concentrate your correlating on those areas. But once again, the correlators are only as good as the operator. You really need to have somebody who knows what they're doing to get the most out of the correlators. unless they do become an expensive thing that just won't work. The other thing I mentioned was the leak noise loggers. If you've done a step test and you've found an area that only has 500 meters to a kilometer, you could put out maybe 5 to 10 leak noise loggers in that area, and you could maybe pinpoint the leaks that way because they'll be listening themselves, and they do it almost automatically then. So that would be another cheaper way, although leak noise loggers are not that cheap. Do you have 2019 figures? Once again, I was only using the figures from the SPAN document, but as I mentioned, MWA is coming out with their report. I've forgotten what it's called, the water something report, which I'm sure will include the latest NRW figures. How to manage NRW in underdeveloped states like some regions in India. I think it's the same as anywhere really, whether it's in Malaysia, if it's in the UK, or whether it's in India. It all comes down to the finances, the economics, and it's what people are paying for their water, what they're willing to pay, and based on that, how much you can spend. What you don't want to be doing is spending a lot of money reducing your NRW to very low levels when it's costing you more than you're actually going to get out of it. So I think any of these water utilities, even if they're in India, you need to look at the revenues. You need to see how much money is coming in, do the water balance to figure out on the revenue side, how much more revenue could I get coming in if I was to improve the customer metering? And then once you've got your revenues sorted out, then you can figure out how much money you've got to spend on the other activities, like putting in DMAs, putting in PRVs, doing leak detection. Please include best practice for meter replacement program for next webinar. And its normal life. Like I mentioned, and I think there's going to be a screen coming up in a minute, the next webinar, which is next week, is actually going to be on customer metering, including AMR as well, I believe. Does DMA formation of water network being implemented at every state? It's a good question. Like I said, the only state that I haven't been to is, well, I have been there, but I don't know, that hasn't had a holistic program is Perlis, but I know that every other state in Malaysia has got DMAs installed. And it wouldn't surprise me if Perlis has also got some DMAs already. What percentage of the effective level of leak noise equipment used reduces pipe leakage? I mean, they all reduce pipe leakage. If you go back 50, 60 years, there was no electronic equipment. So the only way that people did leak detection 50, 60 years ago was to use a mechanical listening stick. And we had people that were so skilled that they could listen to a fitting and they could tell you where the leak was if it was 5, 6, 7, 8 meters down the road. So that was just the skills that were built up from people using mechanical devices. Nowadays, we have these electronic devices which make it a bit more easier to listen to the leak noise, especially as we've got more background noises now. But they're all effective in finding leaks and reducing the leak levels, But of course, you need to have the skilled people to use them. It's like taking somebody who's never driven a car before, putting them in a car and say, okay, please drive down the road. They won't be able to do it. But if you have somebody who's been driving for a number of years, they've obviously got the skills in driving. Should mains replacement be considered as an NRW program, as it is the least effective program in terms of financial payback? Is it more suitable to be classified as asset replacement program as it improves customer service? Yeah, I mean, I wouldn't consider mains replacement to be included as an NRW program, mainly because, as I mentioned earlier, it's more of a CapEx issue. A lot of these pipes that you're putting in, they're going to pay back over 50, 60, 70 years, you hope. So it's more of a CapEx program, and especially if utilities don't have the money to be able to invest in the percentages of pipes that I was mentioned earlier. If your pipes are only going to last 50 years and you need to replace 20%, 2% per year, then you won't have the money to do that. You need to borrow the money. Either it comes from PAAB, hopefully, or it comes from other funding. But that money that you borrow needs to be long-term borrowing so that you can pay it back over the lifespan of the pipe. So this means that it becomes less of an NRW program, but more of, like you mentioned, an asset replacement program. Do you think smart water meters with IoT will help reduce NRW? Well, depends what you mean by NRW, because if you have meters, what meters do is they meter your revenue. So they don't reduce NRW. NRW consists of your leakage, your overflows, your unregistered customers, your faulty meters. So what your smart water meters will do is they will actually help you to get your revenue across. What they may do is they may detect when a meter starts to fail or it can reduce, but water utilities can also do that with their billing system. If they know how much a customer is roughly spending every month or using water, they can monitor if there's any drops in consumption on meters. So don't get me wrong, smart water meters are good. They will help utilities, especially using them in condominiums and office blocks where you have a lot of meters and in that situation. But in terms of reducing NRW, probably at a minimal level. You said earlier about rehabilitating all pipes in one DMA if you're continuously repairing 50 leaks every month. Can you share the rules, the number of leaks repaired versus the need to thank you. I don't think there's a rule, but if you have a DMA, what you can work out is how much would it cost me to replace those pipes? That's an easy thing to do. You can get a quote or work out how much it will cost to replace those pipes. And then what you do is you compare that to the cost of doing leak detection and the repairs every month. And you can then work out what the payback would be for replacing those pipes. So it might be if you replace all of those pipes, you would pay back in, say, a year or 2 years of doing leak detection and repairs. So that's the way I would look at it, is look at the cost effectiveness, comparing pipe replacement to your active leakage and repair. are you aware of knowledge sharing and training initiatives regionally for best practice? I know in Malaysia that MWA has its in-house training team that does training on a regular basis. But also a lot of utilities will have their own training centers. So I know, for example, Johor has its own training center where they can train their staff to do things. So I would assume that there are also other utilities in the region that have their own training centers. But you're right, it is fairly limited in terms of how much training there is. And is it something which is certified? Probably not. So maybe that's something for somebody to think about developing, where you get proper training and a certification which can be used later on.
We have the polls up now, Gary. Do you want to answer all the questions, or would you like to answer them via email to the participants?
Okay, I can do. But I don't mind answering. Am I
Okay.
running over time? Oh, it is. We've been going for 90 minutes already, yeah?
Yes. Would you like to continue answering them? I mean, we are okay with that.
Yeah, I don't mind answering. Yep, no problem.
Okay. I see the polls up now, so
okay.
Perhaps we can give you a little break.
Okay.
And, yeah. So we would like to ask all our participants to take part in this poll. There are 3 questions. The first one is now up on the screen. So kindly key in your answer. Maybe show the second question. For the poll. Okay, so this is the result of the first question. We have a slight technical problem. We apologize for the delay. So we can see the result of the first poll with 74% agreeing and 26% disagree. You there, Gary?
Yes, yeah, I'm still here. Do you want me to carry on with the questions? There's only a few left now.
Okay. Yeah, I think you can, do you see the second question up already for the poll?
Yeah, the second poll's on and the results have come up already.
Okay, all right, because I'm not seeing it.
Okay.
Okay, so maybe Gary, you can continue with answering the Q&A.
Okay. So the next question is, lots of places around the world use smart sensors and making water networks smart. Should Malaysia move to smart networks, or do you think lower NRW is needed first? Well, I think Malaysia already has smart networks. I mean, most of the utilities have already put in flow meters at the treatment plants. They put flow meters in at DMAs. They have data loggers on these flow meters, which send information back, pressure and flow. They have leak detection equipment, which is all smart as well. A lot of that leak detection equipment runs off of modems, so it sends the data back and does automatic analysis. They have pressure management systems that are automatic as well. And they also have trunk main analysis as well, transients and leak noise. So I think Malaysia, I would say that Malaysia already has very high smart sensors. It's the issue, or the next issue, is actually managing and analyzing all of that data that's coming in to make sure that you're using it to its most effectiveness. Can you share the best activity or program DMA to control and reduce NRW after successful implementation? So the first, I mean, it's what I've mentioned today. The first one is to continue with the meter replacement program, which is normally done in most holistic programs. But you need to continue that with all of the meters that are getting older year by year. You need to have a team which is monitoring all of the data, the DMA data and the production data, so that it's analyzing how big the NRW problem is and where to identifying where the problems are, and then doing the active leakage control and repairs, and then doing the mains replacement. Those are the key activities that need to be done in-house by the utility once the contractor has gone. How can culture be changed in an asset management organization? Yeah, it's not easy. And what we find is that a lot of utilities, especially in Asia and Malaysia, they come from a public works background. So it's like a government, the way that the governments operate. And so there's a culture, a public works culture, especially associated with CapEx or project-based programs. And so that's one of the big cultures that needs to be moved. But then there also needs to be a culture which for asset management or non-revenue water, which needs to come from the top down. It needs to come from the senior management. They need to be the people that emphasize the importance. because the people below, the managers and the workers, or the engineers and the workers, they will resist change. Everybody resists change. They don't want to change. So it needs to be the managers that hopefully can encourage the change through incentives maybe, but sometimes you do have to force that change down. I work at a water service company in West Sumatra, Indonesia. We have a little investment to reduce the NRW. What should we do to reduce NRW with low costs and high impact? So the first thing has got to be checking your customer meters. Make sure that your customer meters are working, because I guarantee you'll have some meters that are not working. You need to replace them and get them working. And then replace meters based on age. The older meters, anything above 10 years old, replace them and get more meters in there, new meters, so that your revenue starts to come up. If you've got large customers, commercial, industrial, make sure that you put good meters on them, maybe electromagnetic or just good mechanical meters. So that's the first step, is to bring your revenue up so that you've got more money coming into the utility. The next step is to do a water balance. And the first thing of the water balance is to make sure your treatment plants have got good meters on the outlets so that you're measuring your production properly. Once you've got your production done properly and you've got your revenue up, you'll be able to get a really accurate level of non-revenue water. And that will then give you a start, where to start moving on to the next steps, which is leakage detection, district metering, pressure management. Penang has one of the lowest water rates, yes, and yet manages to keep its NRW figure very low. What is the main point that distinguishes it from the rest, in your view? Yeah, it's a very good question. Probably if you look at the slides that I showed, they are one of the utilities that has been doing NRW in-house for a very long time, 20 years or more. So they've obviously gained a lot of knowledge and skills in managing their NRW in their area. So that helps a lot when you have a program which has been going on for a long time. Penang also is a smaller area. So because if you have a smaller area, you don't tend to have as many big trunk mains. So that helps a lot as well, long lengths of trunk mains. So that can help a lot as well. But once again, it all comes down a lot to the management. So I'm sure in Penang, there's a lot of effort being put in from the management downwards to make sure that NRW is something that's a critical factor. If you look at all of the utilities that have got low NRW, Malacca, Johor, Penang, and you look at the management there, they are the ones that have been really emphasizing the importance of non-revenue water to ensure that it's reduced. Is it necessary to model your network to reduce the NRW value? I assume you mean hydraulic models. So no, hydraulic modeling is not necessarily something which will help you to reduce your non-revenue water levels. But what it will do is help you in your operational efficiency or understanding how your system is operating. And it will also help you to plan some of your NRW programs, especially your pressure management programs and your DMA design. Can you simply analyze causes of high NRW through log data of flow and pressure in a DMA? Yes. So when we're looking at logged flow in a DMA, we're looking at night lines. So we're looking at the flow at night because we assume that most people are asleep at night. Even factories, we hope, shut down at night. And also a lot of commercial entities are not working at night. So that means that the majority of the flow into your DMA at nighttime is what we would consider leakage. Then, if you take the non-revenue water, the flow into a DMA for 1 month, and you take the billing data for 1 month for that DMA, you can work out what the total NRW is for that DMA. If you subtract the total NRW and the leakage, it comes with your commercial losses, your metering losses. So just by having logged flow pressure data and the billing data, you can actually calculate total NRW, leakage levels, and commercial loss levels, which can help you then plan your works. Can you explain the best plan to reduce commercial losses besides replacing water meters and reclassifying customers? Well, the other two are what I've already mentioned, which is the meter reading. So if you're in an area where people are still doing hand meter reading on paper, it's not very good. And then the billing system as well. Those are key. If you can get an automatic billing system in place and a handheld recorders, then they will help. But meter replacement fixes 90% of your problems. How important is DMAs? DMAs are very important in, if you have, we looked at NRW, for example. Let's look at, say, a state that has 30% NRW. I can guarantee you that that state would not have 30% across the whole state. Some areas will have 60%, some will have 10%. And you need to identify which ones have 60 and which ones have 10. And that's where your DMAs help. Your DMAs help you to break down your state into smaller areas so that you can analyze them all and identify where your key problems are, so that you can then send your staff out so that they would make the most effort. Changing water meter is the easiest and quickest way to reduce NRW. Therefore, the actual work of fixing the leak is more costly and tedious, and to bring NRW figures to the teens or single digit will be exponentially more expensive. What would be an ideal balance from your point of view for an achievable happy medium for NRW? Yeah, it's very true. As your NRW levels come down, it actually becomes more and more expensive to fix the problem, because you're trying to find more harder leaks and smaller leaks. You're trying to find any hidden problems, such as customers stealing water, and they can be very careful, and also small percentages of errors in your customer meters. And that's why people tend to work out what an economic level of NRW is. So this is the level where it breaks even, how much you spend on reducing your NRW with how much is being lost. And that's why if you look at the two states, Malacca and Penang, they got down to just below 20%, and they haven't, and they got down to that maybe 4 or 5 years ago, and they haven't gone any lower. Because it's not economic to go any lower. That's why most utilities work out what their economic level is, and that's what they're aiming at. And we got the final question. What is the most causes that contribute to NRW? The two big ones, especially in Malaysia, are meters that inaccurate meters that need replacing, and leakage, the two big ones. So you need to replace those meters for the inaccurate meters, and the leakage, you either need to do leak detection and repair or mains replacement, as I've mentioned in the presentation. Okay, I managed to get through all the questions. So if anybody has any more questions, they can always email me. I see there's a few emails coming already asking for the slides, which I will send out later. And thank you very much.
Thank you. Thank you, Dr. Kade. and the Malaysian Water Association for hosting today's webinar. Thank you, Gary, for sharing with us the Malaysian experiences today. I know you have spent quite a lot of time preparing for today's presentation. So thank you, everyone. We appreciate you being here today. And we have scheduled the next webinar for 12th of May at 3 o'clock. So our next webinar will be on financially sustainable approach towards smart metering. And we will be joined by two industry colleagues, Mr. Knut Bond and Mr. Marcus Chang from Chemstrap Asia Pacific Sdn Bhd, who will be sharing with us insights and strategies towards a financially sustainable smart metering infrastructure that would also bring multiple layers of value by utilizing data that a smart metering infrastructure provides. So we look forward to your virtual participation next week. For updates, please follow our Malaysia International Water Convention Facebook page. Thank you, everyone, and a very good evening. Bye for now.